Hello guys, how is going?
Hello,
Hi.
everyone.
Hello. Good. So, as a because the other two are directly related to TC39 committee, I will use my 20 seconds of fame and ask, well, and how it is going for the committee on with all this isolation? How do you feel about it?
Well, we switched to a completely remote working mode. Previously, we were, coming together 6 times a year, flying from all over the world, and we switched to having video calls. In my experience has gone very well. I think we're able to do the kinds of things that we did before. Just we don't have the kind of hallway track. We don't have the time to as informally. So you have to construct those conversations more explicitly. But I was already frequently calling GC39 meetings remotely, so for me it was not a problem at all.
And Sergey spoiled that to serve us a best quality content. He rented a room in a hotel today. So, what about you? How all remote things affects you? Sergey?
Me? Oh,
Yeah.
remote meetings. Yeah, I was at offline meetings only once, and I think that remote meetings are going really great. I think everybody is satisfied with how it's going.
I'm asking just because, preparing for today's talk, I've occasionally found my frequent flyer card and realizes that I miss flying over the world a bit. I miss also great people on the HolyJS, both in Moscow and St. Petersburg. Do you have, Daniel, I have a very quick question just before we start. Do you feel that all this situation helps you to be more productive and move JavaScript forward faster than if it will be on site?
Well, maybe they don't have as many other things happening in my life now, but also it's distracting situations. So I think it's kind of neutral.
Okay.
Things were already getting better and better in TC39, I think, and the trend has continued. But it's unfortunate the situation.
I see. Well,
I was actually
already pushing for
could
more
you please,
remote meetings.
Daniel, could you please turn off the video and stay only the sound? Our producer asked you.
Yeah.
Okay, I apologize for the video quality.
Internet is hard. Yeah, I believe I can't wait to hear your talk. So we should start.
Yep. So here's my talk. I want to talk about one potential future for JavaScript, where we could have JavaScript module blocks and native bundling. So as in the introduction, my name is Daniel Ehrenberg. I work for a company called Igalia. We're a free software cooperative working on many web technologies and other low-level technologies. And so I wanted to talk about JavaScript modules. JavaScript modules are, they're here thanks to ES6. So you can export functions from one module and import them to another module. And this can help you compose code better. It's a lot more direct and readable than the old CJS or AMD ways of using modules with require. And it's also more statically analyzable. So it improves the ability of bundlers and tools to analyze and transform code. So there are a couple different goals that we may be able to achieve with JavaScript module I wanted to discuss. One is to run more JavaScript code in parallel. So we have workers in JavaScript in the web platform, and now also in Node.js. Workers let you can create a new worker, and then the worker is in a separate script, and you can send a message to a worker with post message and make something happen. Now, in some browsers, you can create a module worker. So if you just pass type module as the second argument to the worker constructor, then this is interpreted as a module. You see the code is exactly the same in this case because there's no difference here, because modules generally use the same syntax as scripts, except for imports and a couple edge cases. So this just works to upgrade to a module. But it's kind of annoying that you have to write a separate file just to run code in parallel. And this also has impacts with bundlers. It can be harder to configure bundlers to make. So module blocks is a solution. With module blocks, you could make a module contents line in a script or module, so then you can use it as an argument for something like new worker. So this makes it so that you can run code in parallel without switching to a different file. So what are module blocks? It's a piece of code that's independent of a context. It operates as a module specifier, import from any realm. So when I say modules, what I mean is it's something that you can pass in as an argument to import. So we're passing it as an argument to new worker, because the first argument to new worker is a module specifier. Here we're passing it as an argument to import. And in either case, import returns a promise. And once you await that promise, using top level await in this example, you can get the exports. And because modules are cached, if you import the same module block multiple times in the same context, in the same realm, then you get the actual export object. So one key thing here is module blocks don't close over anything. They don't close over anything because it's possible to write a module block in one place and then run it in another place. This is key to the realm example, because key to workers, because workers run in a different thread and JavaScript memory is single threaded. So if this were a closure, if it closed over anything, it would have to somehow transfer that thing. Instead, the module is evaluated in the place where it's imported. So it's evaluated in that other worker. So module blocks are at stage 1. The champion is Surma, Chrome developer advocate, and you can find the proposal here. Now it's at stage 1 in TC39. So another goal that I have is to load JavaScript modules natively and efficiently. So right now, modules, you can load them with individual fetches. So, HTML supports modules to be used directly. You can have import statements, and what you use as the module specifier is the URL. But this often runs too slowly to be used in practice. So it's good that it uses the JavaScript engine's module implementation, but it's often too slow. And back when this was standardized in 2015, 2017, there was a lot of optimism about each saving us and making this possible, but it seems like these improvements are not going to come automatically. So instead, we have bundlers. We have things like Webpack, Rollup, and what they do is they take many different modules and make fewer modules to reduce overhead. So this emulates this. They emulate the semantics of ES modules rather than running the modules directly. So when module blocks presented, many people were very excited, thinking that this would solve the module bundling problem. So could it? Maybe it could in some. So if you have these module blocks, you can import them with top level await, and then use their exports. So could this maybe be the basis for bundling? The problem is that this doesn't work when the modules import each other. When modules import each other, they just can't reference each other, because this count needs to reference the lexically scoped variable here. Modules don't actually close over their lexical environment. So this sort of doesn't make sense. Instead, we would need modules to be declared to have a binding in the module map. So the HTML standard refers to the mapping from module specific to module to sort of the actual contents of the module as map. So we could have a file that has a bunch of modules which are declared like this. You have module and then the specifier, the URL of the module, and then curly brackets. And then these could be placed in the map such that when you have the import statement here, import just works. We could call this JS module bundles. So this would be kind of a declarative way of putting multiple modules in one file. The semantics here would be that when you reach one of these module statements, it puts this module inside the module map so that when it's imported later, it avoids an HTTP fetch. So once the module bundle is loaded, then the modules could be imported from anywhere, not anywhere inside that same window or their kind of realm, not scoped in any further way. I want to talk about an alternative. I mean, this idea seems pretty nice, but I think if we want to add a native bundling solution to the web platform, we can do more. So the alternative I want to discuss is what you might call resource bundle preloading. This is based on work from other people in Google and Brave. So in Google, there was extensive work on this web bundles proposal. And in Brave, there was skepticism raised about web bundles. What I've tried to do here is sort of combine the best parts of both analyses. So a resource bundle is a map from paths, from URLs to metadata plus a payload. So the URL is sort of the module specifier here, and the payload is instead the response body. So this lets you specify your own choice for how these are interpreted, because you might have JavaScript files, but you might also have WebAssembly files or images or things like that you also want to bundle. So preloading a resource bundle could work like you have a link tag that specifies what you want to preload. So you specify the bundle URL as well as the resources inside the bundle that you want to preload. And then you can use them not just but in any place where you would fetch a resource. So style sheets are not fetched from the module map, they're fetched separately. But if we have a resource bundle that works at the HTTP fetch level, then it could it could also bundle these resources in. You also may want to have an imperative API, this preload bundle function, that would similarly take this href in this list of resources and return a promise that resolves once this preload has occurred. So the idea of the semantics is one change is to be a little bit more cache friendly. So you have this resources list. Some of these may already be in the HTTP cache. If it's already cached, then you don't want to download it again. You instead want to, sorry, just a second. You take the subset of the resources that are not in cache, because if something's in your HTTP cache, you don't want to have to download it again. And then you send a message to the server asking for a subset of the bundle that contains just those resources. When the response is returned, then you insert each entry into the HTTP cache. So then when you later need to fetch an asset that was preloaded, you load this from the cache that is efficient to load because it's in browser memory. It could also be cached on disk for later accesses. If there's a bundle preload that's in flight, if it races, then the semantics would be to wait for that preload to occur. The hope is that the memory caching would reduce IPC costs, which I'll talk about soon. So to compare these two solutions, there are a number of differences. One is the text-based format versus a binary format. So JS module bundles, because they're based on a text-based grammar, they can only support JavaScript. If you had a WebAssembly module, then you would have to kind of base64 encode it, which would reduce efficiency. A separate issue is the the separate issue is random access. So if you have a resource bundle, if there's a mapping at the beginning of the file, which is the binary format of resource bundles, there's sort of a directory at the beginning of the file that points to the list of resources, then this allows random access faster. It does require new tools. A separate level is the difference between the module map or fetch. So this is where we're indirecting. With JS module bundles, there's an entry inserted into the module map. With resource bundles, they work at a lower level. They work at the level of fetching something from HTTP. So this works for all sub-resource loads. So somehow it's more expressive, but also might be more expensive, depending who you talk to. Engineers from some browsers say optimized, other browsers say this will continue to be expensive. There's also difference in caching. JS models are cached atomically, all in one. And on the other hand, resource bundles are subset based on the contents of the cache. So fine-grained versus coarse-grained caching. So I wanted to talk about the trade-offs between the possibilities. One way of looking at these trade-offs is in loading performance factors. So many different things affect loading performance. Bundlers have been working on optimizing these and done a great job. But to talk about the trade-offs between individual resources and current bundlers, for one, you could think about this loading waterfall. With individual resources, we really want a vertical line in terms of when things are loaded, how that affects the load time. You want to need for all the resources immediately. If you have a deep module graph where things reference each other, then you have to fetch one thing to discover that another thing is needed. You can insert preload commands, but this is kind of difficult and imperfect, whereas bundlers handle this. There's also per resource overhead. So depending on the environment on the web, each OS or JS, Node.js file system access has cost. And with bundlers, there's fewer resources needed, so there's less overhead. Emulation with bundlers today transforming into JavaScript, they may represent various different file types as JavaScript strings, which adds a huge amount to the cost. Whereas, on the other hand, individual resources are not emulated, so they can be interpreted directly by the browser. Inter-process communication. In web browsers, there are processes that are used to provide sandboxing to make to improve security, and sometimes the communication between these different components can be expensive in itself. So some data from the V8 project showed that even if you insert all the preload commands, there's still a lot of processing time in Blink to deal with all the different network requests. This may be inter-process communication, and some maybe other kinds of bookkeeping that has to do with resources. But it's a real significant cost of individual resources compared to bundling. With compression, you want to compress things. If you have a big chunk of data, then it can compress more efficiently than several small chunks of data because the compression dictionary is shared. So with individual resources, you have a worse compression ratio, and bundlers improve this. And code splitting, so individual resources are kind of maximally split. There's been a lot of great progress splitting and ensuring that a minimal set of resources is loaded. In the case of bundlers, but still it's difficult to configure properly. So for example, if you optimal code split where nothing is downloaded that's not needed and nothing is ever downloaded twice, then that can lead to many different small chunks, which leads to the other kinds of overhead that I've discussed in other slides. So it's a difficult trade-off. With parallel processing, if you have things in small chunks, it can be better for parallelism because it's easier for engines to compile code in parallel if they're broken up into different scripts or modules. So chunking the right chunk granularity that's kind of intermediate can expose parallel processing, but it's a tricky balance, whereas individual resources solve this perfectly. Similarly, for streaming, the web platform is designed from the beginning to be able to execute things before everything is downloaded. So even if they're not executed, there can be interpretation done ahead of time. But with bundlers, especially if you use this pattern of putting resources in JavaScript strings, then they can't be interpreted until that JavaScript runs to execute them. Caching is another trade-off like this, where with individual resources, caching has been included since the beginning of the web, that resources are found in cache, and so it's not necessary to download them again. But bundles, by default, if they're treated as an atomic unit in the cache, they have to be downloaded again if changed. So chunking can help, but it introduces this trade-off about chunk size, where this is one reason to have a smaller chunk size. There was an idea to fix this in HTTP2, much like there was also an idea to share the compression dictionary between responses. But due to security and complexity concerns, these these ideas are not currently forward. And so it doesn't seem like those will happen, and HTTP won't make things magically cheap and cached and compressed all perfectly, unfortunately. So if you look at all these together and we think about the different options being discussed. So in terms of waterfall, bundling handles this, and so all the different kinds of bundling ensure that the resources are preloaded before they're used. In per overhead, individual resources have significant cost, but and resource bundles, they may have some cost because they indirect at the fetch level, but bundling in JS modules would probably have the lower cost. So it depends kind of which performance theory you believe, whether resource bundles will have significant per resource overhead. In terms of emulation, unfortunately, in bundling today, as well as JS-only module bundles, you may end up emulating non-JS resources in terms of JS represented in strings or some other way. Whereas resources or resource bundles, that's unlikely to occur. In terms of interprocessing, individual resources are cause this overhead, and the other bundling strategies don't as much. For compression, all the bundling strategies help improve compression. They help compression by bringing everything into one unit, which is compressed together, so the compression dictionary can be shared. So you can think about all these and see that there are these various trade-offs between the strategies, and we really could make in terms of loading performance. Potentially, this would need to be verified with test implementations, but I hope that there would be a benefit by adopting these strategies. In terms of code splitting, with resource bundles, because you list the subset of resources that you want at the site when you import it, there's less need for splitting to be sort of ahead of time or chunked in a certain way, because it can be entirely dynamic. You list the subset of resources that you want there. This would need tools to identify the list, but that's something that I'll come to later. Caching is also handled very well by resource bundles because the browser's cache is involved in fetching the bundle. And finally, the streaming idea is that because the browser can read the bundle, whether we go with JS module bundles or resource bundles, because the browser can see into it and understand the format, it's possible to start evaluating it and start at least compiling it and processing it before the whole thing is downloaded. Whereas with bundles today, in a big JavaScript bundle, the browser is required to check that it doesn't include any early errors, any syntax errors in JavaScript before it can start really compiling or doing anything with any of it. So it doesn't work very well for streaming. One particular point is this tension between compression and caching. For compression, it's good to have many different things compressed together so that they can share in dictionary. But for caching, it's good to have a fine granularity to avoid duplicate loads. So this makes it hard to choose a good single chunking granularity. This resource bundle preloading can get us the best of both worlds. What the server to do is to get the subset of things needed to dynamically recompress it. So this lets things be compressed together, but cached individually for more efficiency. Also want to talk about privacy. So if you've heard about web bundles before, you may have heard about this blog post from Brave, where Brave said that web bundles are harmful to content blocking and security in the web. This is a very serious concern. So I want to dig into the various privacy concerns that have been raised with bundles. One concern is around the origin model. So if everything in the web platform is based on the concept of an origin, you have the origin is sort of the domain name. And if something comes from an HTTPS origin, then it represents that origin. This is used as a security boundary in many parts of the web platform. So if we have a concept of they would only be able to things in the same origin, and even more strictly, probably in this directory, not representing something in another site. Their bundles have long been mixed with the concept of signed exchange. They're both being developed in the same repository, and I'm not a big fan of signed exchange. I'm worried that this pushes everything to be used centrally. Signed exchange and bundling really don't have anything to do with each other, and it's important in my mind to decouple them. So Brave's blog post focused on web bundles with this idea about web bundles being somewhat decoupled from signed exchange, but even if the documents don't currently support that. But there's another question about URL semantics. If bundles represent what the contents are of different URLs, its importance doesn't preclude content blocking techniques. So content blockers or ad blockers today use the URL as a thing that they can sometimes regular expression queries on to check what they should load and what they shouldn't load. And if bundles allowed sites to randomize that more cheaply, then it could make it hard for content blockers to work. The bundle contents should be named by the URLs, and the URLs should be the same as what you would get by loading them individually. So in terms of tracking, Apple raised a concern that bundles could provide a cheaper way to track sub-resources. So imagine you had a bundle that had a little identifying token that was present in each piece of the contents that the server could randomize before sending a response to a user. So then in a way that's actually stateless to the server, both of these have in common an aspect of statelessness to the randomization. If it's stateful, you already could do this, but bundles make it more powerful. Then the server had you a bundle, and that would provide a way to associate the resource. So the takeaway principle is that bundles should be served the same way to everyone and not personalized. Finally, in terms of content blocking, so content blocking like, for example, ad blocking or blocking tracking. Content blocking today works by skipping loading individual sub-resources that are undesired. If everything is bundled, the gains from content blocking are diminished because you can't avoid the overhead of loading the undesired resources. So the ideal would be if protocols that we adopt permit the browser, the content blocker, to opt out of loading some of those resources. So thinking about JS module bundles and these privacy goals, the origin model is sound. We're only representing things in the same origin. In terms of URL semantics or tracking, I think if module bundles are served the same way that modules are today, they could be used to serve different things to different people. And so this could this could allow URLs to be kind of randomized, or to these tracking vectors to be added, though arguably it's not any worse than what rollup does today, because it's only being used for JavaScript. It may not be so bad. In terms of content blocking efficiency, because you're loading the whole bundle all or nothing, and there's no way to block the network overhead of some individual script that the browser decides it doesn't want to load. Whereas this resource bundle preloading idea does meet these privacy goals. So in terms of URL semantics, we say the servers must serve each item within the preloaded bundle at the same URL. They must serve them individually as the same way as they would serve them in the bundle. Talk on the next slide about an enforcement mechanism. In terms of tracking, requests are. I'm proposing that requesting a bundle is an uncredentialed request, meaning cookies are not sent, and plus this anti-personalization scheme. In terms of content blocking efficiency, content blockers could treat resources that they're not interested in just like the same way as they would treat them if they're in. So they only ask for the sub-resources they need. To enforce URL semantics, the main idea is that browsers can decide if they want to load from the underlying URL, the URL indicated, and ignore the resource bundle. There are a couple different strategies that browsers might want to adopt for this to decide when to load from the underlying URL. One is an offline easy list A to track ads, where you scrape the web and you check which origins are serving bundles that don't match their contents fetched individually. Another strategy that browsers could use is online. For a small subset of fetches to the resource bundle, you fetch the URL redundantly, and if there's a mismatch, then now you know to kind of not trust that bundle. So if the mismatches are detected, then we can simply stop paying attention to the bundle preloads and load the URLs directly. So I think bundle preloading does meet these important privacy goals. Some more possibilities with bundle preloading. It could be used as a convention within servers and build tools to one thing within build tools would be to break this resources list, because it would be rather long and annoying to write by hand. Another advantage would be to help configure HTTP servers better, a static part of the website. For example, it's often important to set headers, but different servers have different languages for configuring HTTP headers. The metadata section inside of a resource bundle could be used on the server side to indicate those headers. Ability. I mentioned streaming. We have in JavaScript the semantics that when you import a module, the whole module graph that's imported is executed atomically. We could relax this and instead say that things are executed incrementally when they come down from the network. This could also improve performance further. It's possible that bundles could be used as kind of a unit of atomicity to decide when to do update. So currently, the state of the art is to put a hash based on the contents of the resource in its URL and to give a long-lived cache lifetime to that resource, and then change the URL that you're referring to it when it changes. We could instead think about other schemes, maybe based on e-tags or other kinds of version numbers, to subsume this and allow for consistent updates without changing URLs. There are also ideas for how we identify the resources list more implicitly, maybe with a manifest at the beginning of the HTML file, rather than having to write it explicitly each time. I want to investigate these, but I'm also trying to focus on a minimal core at first. So the thing that I'm really most interested in investigating soon is resource bundles being used in building and serving. I think this proposal would only be feasible if it's based on the cooperation of the tools ecosystem in JavaScript, who's been, tooling authors that I've been in touch with have been very interested in this area, and I'm really happy to be starting to work together with everybody here. We could use a resource bundle to represent the whole static part of a site. And so frameworks or JavaScript could output resource bundles. Bundlers could be responsible for filling in this resources list. Minifiers or other kinds of optimizers, Cursor expressed interest in this, could transform to a bundle. So this could be a standard way to represent a package of that can be used as part of a build pipeline. And finally, servers could take a resource bundle as input to serve inputs and to serve subsets of the bundle as requested. So I hope that this could have some impact in terms of improving interoperability and reducing configuration of systems used to build and serve websites. So I've in the past where I explained how JavaScript standardization works in TC39. For me, this would be my first time working in these other standards bodies, at least to be working on it as much as I'm working on this project. So we'll see how it goes. This is still a fairly new project. If we wanted to do JS bundles, they would make sense as a TC39 proposal. But binary formats like bundles they tend to be developed in IETF. IETF has a number of important specification tools, like there's this binary format called CBOL and a schema for this called CDDL that would be great for specifying this kind of binary format. For the loading specification, this would be standardized initially in something called the Web Incubator Community Group, the WICG, which provides kind of intellectual property protections for early developments. And then eventually it would make its way into various different specifications for the web in W3C and Uptake. So I wanted to discuss this topic more. I'm happy that this conference has a Q&A section. And so on my understanding of this space, I think general resource bundle preloading would provide really significant benefits versus JS-only bundles. We could have both even, but I'm wondering what you think, if this seems persuasive. So far, I've heard a lot of excitement from developers about JS bundles, but also about these more advanced kinds of bundles, and I don't know how we should think through the trade-offs. Mm-hmm. So do you think this is a good idea? Is it important to bundle non-JavaScript resources? Do these optimizations that discussing make sense? Is it adding too much complexity for the potential performance benefits? A lot of people have commented that it would be better to improve HTTPs or improve bundlers to get these potential gains. Does it make sense to be introducing a new file format here? And are people interested in these different extensions? So I guess I have 10 minutes left. That was the end of my slides. I could present more about this, or should we go to questions?
As you wish, probably. As you wish. I will be happy to have a discussion or anything like that.
Let's have a discussion, and then if we run out of discussion, then I can present more specifications. I don't know.
Yeah, I believe Sergey is a big fan of reading specifications, so he will definitely love that. But I have a very, very first question personally from me. What concerns me a lot, and I would be happy to hear your feeling about that, is that browsers which will be implementing this concept, I'm speaking about browsers in a broader term, not just JavaScript engines, became more and more complex, and their complexity is, as I feel, comparable to operating systems and so on and so on. There was some time a concern that creating a new browser on the market is close to impossible in terms it will cost a lot of money and development effort and so on and so on. How do you feel about that? How do you feel about making this web engine, browser, so complex?
That's a really interesting question, and I guess my job is in working in what is all about making the engine more and more complex. Personally, I think the biggest problem is financing. In general, infrastructure work is hard to finance. It's hard to build the business case for something that everybody the benefits are dispersed, but the costs are concentrated. So this leads to a space where, you know, one browser engine is investing much more than others, and it's just hard to, with all the browsers being kind of free and open source, you're not selling Netscape Navigator anymore. It's hard to build a business model around it. So I think it makes sense to maintain multiple browsers. I'm hopeful for the Servo Foundation in terms of continuing development and building another full browser engine. So Igalia, my employer, is a consultancy that works on browser engines. We work on all different engines. I mean, the 3 browsers that there are remaining. And it's always a question of when does it make sense for anybody to sponsor that work? Sometimes it makes sense. A lot of times, I'm kind of hopeful that there will be more contributions from more broad contributors into browsers, because it's hard to expect that just a couple of corporations pay for everything.
Yeah, you made me feel a bit of nostalgia because the Opera software was the first software piece I've ever paid for long ago, when you talked about not selling Netscape anymore. Yeah, we have a question. Yeah, sorry, go on.
Oh, sorry, go on. I'll ask it later.
Okay, so we have a question from chat. When we speak about bundling, there is one big pain point which always comes into the mind. It's versioning. Like for now, we have hashes or whatever in the file names. How the proper invalidating cache, which is especially important for content delivery networks, is approached within this proposal?
That's a very good question. So within the resource bundles, I think the caching would all take place at the level of what's included in the bundle, not at the level of not at the level of the name of the bundle itself. So the name of the bundle does not make it into the HTTP cache. My understanding from talking with experts in this area so far is that, at least for the initial version of this proposal, you would continue to use current approaches with the content validating hash inside of the URL of the resources that the bundle contains. I think that approach continues to make sense. There's a question of how are the cache headers communicated, and I think inside the resource bundle format, I think the only header that we want to have per resource is the MIME type. There could be, others have argued that resource bundles should contain more metadata besides the MIME type, but I think if you provide cache headers in the response, the whole bundle, those could be applied to each of those sub resources inside the bundle. So you would probably give those a long lifetime or an unending lifetime, and then rotate the URL hashes. Does that seem like a sensible answer initially?
Definitely sounds that for me, but we'll see how it happens. Sergey?
I do want to mention that there's an idea to make a new version number scheme, so that you would have a version logically in a separate header, and in your resources list, you would list the version numbers that you're asking for, and this could replace the content hash scheme. But this is rather complex, and I wanted to separate that. But there are a lot of people interested in upgrading from the content hash scheme. Another idea is port maps to provide a level of indirection between module specifiers, which would be the high-level version, and the content hash rotating lower level. If we could do either one of those schemes, it could have a benefit for caching further, because this means that you don't have to cache of the things, the hash URL of the things that refer to it. So it could improve the reuse of things. So, Sergey?
I have a question about model blocks. As far as I understand, model blocks only can be declared on top level of models, right?
No, they could be declared anywhere in an expression. I don't know if you can see my slides, but look, in this example where you're passing a module directly to a worker, it's not at the top level. I think if we went with JS module bundles, those could only be declared at the top level. But these module blocks as expression could be anywhere.
Oh, so the block could be inside the closure in this case, or
well, in this case, it's not inside a closure. The main thing is that they don't close over anything. So if you have a reference inside of a module block that points outside of the module, then it doesn't, it just doesn't work. It will return a reference error.
So in that case, it sounds like it's possible to parse module blocks in parallel. And do you think that people?
Yeah, that's true.
Do you think that people can start to overuse module blocks to wrap every function in a module block to parse them in parallel to speed up their parsing of their models?
So I'm not sure if that would be a speed up. I don't expect it to be, because, well, first of all, the potential of that is somewhat limited, because you have to find the matching closing brace. And if you have a closing brace that's inside of a string or a regular expression or something, then it doesn't match the same way. So you really do have to parse the whole inside of it. So it would be somewhat hard to parse them in parallel. But I think it would be more easy to compile them in parallel, to compile the bytecode in parallel. Overall, I don't think that would be a very helpful pattern. It wouldn't improve your loading time. And then remember that you would have to import it. You have to do this await import in order to make use the module block. So I don't think that would be very helpful.
Yeah, this does make sense. Thanks.
At least people would not shoot themselves in the leg with all of this stuff. And I also have a question about, and actually we have literally the same question in chat. So do we need to explicitly enumerate resources in bundle, or will it work in the same way as bundlers do? So we can specify the initial module, and module will take other resources from this bundle explicitly.
That's something that we could maybe do with depth cache. So this is a proposal from Guy Bedford about having a mapping, a kind of indirection. Oh, sorry, I'm sharing the wrong window. Having an indirection from from each resource, having a way to find which resources it uses. So then when you load one of those resources, you can jump over and load the other resources. So
yeah, and also in that, yeah, sorry, go on.
Can you see the share?
Yeah.
This would allow you to not have to explicitly say which things you're loading, because you just would say the entry point sources list, and it would fill in the remains. But the cost here is, I mean, the reason we want to list them explicitly is in order to enable do this cache subsetting. The browser will not be able to say which things it has in cache and which it doesn't, if it doesn't know what resources there are until it gets the bundle back from the server.
Yeah, I'm just thinking about this in the light of module federation and all that fancy stuff, which is recently getting hyped in front-end community about micro front-ends and so on. How would a couple, like more than one resource bundle interact on the page? I mean, could I access one resource from one bundle and get it from another bundle and so on?
There was an idea that Jeffrey Askin proposed, that there be a URL that represents a sub-resource from within another bundle that has a different URL. In my opinion, that's kind of overkill, because in my view, the resource bundle represents present at another URL. So basically, if a resource wants to get something from another bundle, it just loads the URL of the thing that it's looking for. And there may or may not be a resource preloaded. There may or may not be a bundle preloaded that serves that resource. It's kind of an optimization.
Just to make things clear, so basically there should never be a situation when you have some resource with some URL declared in the bundle, and this URL is not actually present when you request it directly.
Yes, that's the principle.
Yeah, and so basically it will be browser's responsibility to control that and, let's say, punish the websites which will not follow it for some reason, for technical reasons or whatever.
Right. So what I've heard from different browsers, some browsers may not be interested in controlling this or punishing for it, and other browsers may be interested in that. And that's just a thing that, based on their priorities, like different browsers have different content blocking techniques currently.
Yeah, and sorry, a very last question about multiple resource bundles, and what about cross-origin bundles? How do they, could they interact? Like, are there any differences from typical cross-origin resource policies?
That's a very good question. So I have an example in this gist out resource bundles. I have an example to explain how this would work cross-origin. I think it's important that that CDNs continue to work. If you have a bundle that is loaded from a CDN, then that bundle can represent things in that same origin as the CDN. I think that's the basic principle, that the bundle is only representing things in that same origin. It's not going to represent something in another origin. Does this answer the question?
Well, a bit. So basically,
the referring page.
Yeah, go on.
The referring page does not have to be of that origin that the CDN is.
Okay, so basically we will just to make sure, the whole idea is to make it as transparent as possible. So from front-ender's perspective, who is not that deep into all that technical stuff, I'm just working with URLs, and it's a matter of browser to magically pre-bundle them and get it parsed. If we do not speak about modular keyword, which we introduce, I mean speaking about this bundled version of resources.
Well, your build tools have to construct the bundle, and you have to explicitly use this new link tag in your page, and you need your server to be configured to serve the bundle and to perform the dynamic subsetting. So there is some setup. I think the hope would be that we get this tool story worked out to make sure that this is actually deployable before shipping it in browsers. I think this was one of the errors of HTTP2, that HTTP2 push, there was just a lot of optimism around it. So it was specified and implemented and shipped, and then nobody could figure out how to use it. So to me, it's important to avoid repeating that error.
Yeah, so basically answering another question from our listeners. We do not have the original question was, why not special URL to get a single bundle file and navigate within it? Why to split then merge? It's because we want to benefit from separate resource caching, right? Because we should bundle on the server only things we really need.
Yes.
Yeah. Great. And I have a bit. Sorry, Sergey, I'm a chatterbox, so if you want to jump in, feel free to jump in anytime. Yeah. So I have a bit another question, just a bit general one, and every time I touch a person who is related to TC39 committee, I ask about it. Each proposal, which is usually adds some good things to JavaScript, which is probably makes my life as a front-end engineer easier and better and so on, but growing overall complexity of a language and increasing the time for newcomers, for example, to learn and master this language. How do you feel about ideas of cutting some, let's call it bad features from JavaScript, because since long time the JavaScript is going bigger, and the only time I can remember when we cut the things down was when we introduced use strict, which prohibited us from using several very bad things. Don't you have a feeling that there might be a time in future, in nearest future, or probably never, when we should cut down the scope of JavaScript language?
Personally, I think that it's very hard to remove things from JavaScript because of the constraints of web compatibility. I think the fact that JavaScript never had a Python 3 version transition has been a big advantage to us. We avoided creating all of that friction for users. And we kind of have this with modules, but modules only change certain things. Module, I don't know. Maybe modules are our ES3 moment, but I think it's worth it to some extent. In terms of removing features, there are some features that I would like to consider removing, but there are features that, to be web compatible, to remove a feature, it has to be that nobody really uses it. So things like symbol species and symbol to string tag from ES6, if it's possible to remove those, I think that would be really great. But this will take really careful investment to understand their compatibility impact. So that would be the first step.
Yeah, obviously I'm not speaking about like removing entirely because, well, the sites live too long. It's more about introducing like another mode, like use stricter or use strictest. Just joking, obviously. Like yet another mode.
Yeah. In my opinion, adding modes adds a lot of complexity, and it's something that I would like to avoid in the future. I would like to instead make sure that all the features of the language are available in all the modes. This was discussed in the ES6 timeframe, and there was this one JS concept that some people like and some people don't like, but I like it, which is that developers really think about modes, and everything we do should work everywhere. So I hope we can progress in that way.
Yeah, just one quick feedback, like exactly about this, about the proposal on slides. There is tiny things which makes me a bit uncomfortable. It's about closures. Actually, like usually when I parse with my eyes the JavaScript code, I see, oh, here I'm referencing the variable from this file, so it's available. And now I need to, like, when I'm referencing something with my eyes, and it is still important for me, for example, when reviewing the code in GitHub or GitLab UI or from other people, I need like to understand, we can't reference this variable here because we are using the modular and it will not be available. So this is like a thing which concerns me a bit in terms of how easily it would be to like perform code reviews with introduction of such syntax. Any feelings from your side about it?
Well, I think there's there have been alternatives proposed where we use a curly bracket and a bar when opening and closing it to indicate that the scope is missing. This was in the earlier Luke's proposal, where they used some other this. Personally, I think that doesn't really explain the lack of scoping either. Even if you see the bar, you still might expect the variable to be there. The fundamental thing is there's no way to allow closures. Our only choice would be to require you to write a separate file, because you're trying to send it to a different context, which may have an entirely different garbage collected heap. And if we allow it to close over things, there's no way to control mutability or anything like that. So it could lead to race conditions.
Yeah, for sure. I'm not expecting this to be available. Just making like a feedback
Sorry,
it makes
guys.
things harder.
Guys, I have to interrupt you. Our time is over. It was wonderful talk. Thank you, Daniel. Thanks to such speech, we understand not only new standards or concepts, but also why something works this way and not otherwise. Thanks a lot. You can find Zoom link
Thank
in
you.
Telegram channel. And thank you, guys.